Did you know that on the planet HD 189733b, it literally rains glass sideways? This huge planet orbits very close to its star, and its atmosphere is extremely hot, over 1,000 degrees Celsius. The winds are unbelievably fast, reaching 4,300 miles per hour, strong enough to blow molten glass across the sky like deadly arrows. Imagine a storm where the rain itself could slice through anything in its path. HD 189733b is only 63 light-years away, making it one of the closest planets we can see crossing in front of its star. By watching the planet before, during, and after it disappears behind its star, scientists discovered that it has a deep, bright blue color, similar to how Earth looks from space. This planet is a strange mix of beauty and danger, a place where violent storms and dazzling colors exist at the same time. Did you know that far away in our galaxy, there is a massive cloud made mostly of alcohol? In the giant molecular cloud Sagittarius B2, astronomers have detected huge amounts of ethanol, a type of alcohol, floating in space. This cloud stretches for dozens of light years and is one of the richest regions in the Milky Way for molecules that could help form life. Using powerful radio telescopes, scientists can map where the alcohol is densest, finding it concentrated near areas where new stars are being born. This discovery shows that alcohol isn't just something we drink on Earth. It exists in enormous amounts as a gas in space, mixed with dust and other molecules. These cosmic alcohol clouds reveal how chemistry works in the harshest environments, and studying them could help us understand how life's ingredients form across the universe. Did you know that stars in dense clusters can talk to each other? When two binary stars meet, they interact through gravity, swapping energy, or even breaking apart. These close encounters change their orbits and speeds, quietly shifting the structure of the cluster. Over time, repeated interactions can reshape the heart of the cluster entirely. These gravitational exchanges act like a silent conversation between stars. Harder binaries survive and tighten, while softer ones may be disrupted, sending stars flying. This constant energy flow moves stars in and out of the core, controlling the cluster's evolution. It's a cosmic dance where every star is connected in a subtle, invisible way. Did you know that some galaxies are connected by rivers of superhot gas? These rivers stretch for millions of light years and act like invisible highways, where matter slowly moves from one galaxy to another. They are extremely hot, tens of millions of degrees, but also very thin, so we can hardly see them. Scientists have spotted these gas bridges between galaxy clusters like Abell 399 and Abell 401, showing that the universe is connected in ways we don't usually notice. These rivers might also hide some of the universe's missing matter, the stuff that makes up stars, planets, and people. Space telescopes like Planck can detect them by measuring tiny changes in the light left over from the Big Bang. By studying these cosmic rivers, astronomers are starting to map the invisible web that holds galaxies together across the universe. Did you know some stars spin so fast they are almost flying apart? One of the brightest stars in the night sky, Regulus in the constellation Leo, rotates at nearly 320 kilometers per second at its equator. That's 96.5% of the speed that would tear it apart. Its incredible spin makes the star almost reach the point of breaking apart. This incredible speed squashes the star at its poles and stretches it at the equator, making it slightly oval instead of perfectly round. Astronomers measured this using a special instrument that detects the polarized light emitted by rapidly spinning stars. Studying stars like Regulus helps scientists understand how the biggest stars live and die, and how they create the heavy elements, like iron and nickel, that fill the universe. Did you know some comets smell really bad? Comet 67P/Churyumov-Gerasimenko, studied by the Rosetta spacecraft, releases gases like hydrogen sulfide and ammonia. If you could get close enough, the comet would smell like rotten eggs and horse stables. There are also faint hints of almond and vinegar smells mixed in, coming from hydrogen cyanide and sulfur dioxide. These smells come from the chemicals in the comet's coma, the fuzzy cloud around its core. Even though the gases are very thin and spread out, scientists were surprised by the strange mix. Studying these smells helps astronomers understand what comets are made of and what the early solar system was like. So next time you look at a comet, remember it might not be very pleasant up close. Did you know that some stars actually seem to breathe? Stars like Mira, a red giant in the constellation Cetus, expand and contract in a regular cycle, As their outer layers heat up, they swell and become brighter, and as those layers cool down, the star shrinks and dims again. This rhythmic change in size and brightness happens over hundreds of days, almost like the star is inhaling and exhaling. These pulsating stars are known as Mira variables, named after the first one ever studied. Watching them is fascinating because it gives astronomers a glimpse into the future of our own sun, which will one day go through a similar phase. The changes in brightness are not caused by anything outside the star. It's all due to the star itself, making it a cosmic example of natural breathing on a truly enormous scale. Did you know that some stars can actually eat their own planets? When a star grows old and becomes a red giant, it can expand so much that it swallows the planets orbiting too close. The material from these planets gets pulled into the star's atmosphere, mixing with its own gases. Scientists have observed that giant planets are much rarer around these aging stars, suggesting many have already been devoured. This cosmic planet buffet happens because of powerful gravitational forces between the star and its planets. As the star expands, it tugs on nearby planets, making their orbits shrink until they spiral inward. Some planets break apart, while others are completely absorbed. One day, even our sun will enter this phase, and although Earth might survive, the closest giant planets could end up being eaten by our own star. Did you know that some planets can survive the death of their star? Astronomers using the James Webb Space Telescope have directly observed 2 exoplanets orbiting white dwarf, the remnants of stars that have already died. These planets are similar to Jupiter and Saturn, and they managed to survive their star's transformation into a dense, dim stellar corpse. Even more fascinating, the white dwarfs they orbit are polluted with heavy elements, likely caused by these surviving planets pushing asteroids and comets onto the stars. This discovery shows that after a star dies, some planets don't just vanish. They can keep orbiting quietly, becoming cold, dark zombie planets floating in space. Did you know that some supergiant stars can temporarily disappear from view? Betelgeuse, a massive red supergiant in the constellation Orion, shocked astronomers in 2020 when its brightness dropped by about 2/3. Enough to be noticeable with the naked eye. Scientists later discovered that a cloud of dust ejected from the star, combined with unusually cold regions on its surface, blocked its light, making it appear almost invisible. After several months, Betelgeuse returned to its normal brightness, showing that these stars can hibernate temporarily. This fascinating behavior gives astronomers a unique opportunity to study the life cycles of the most massive stars and understand the dramatic processes that occur in their final stages before they eventually explode as supernovae.